All right, NFLers, Nerf for life. Don't try to creep. Let's keep on pressing on. Example number 4. We're going to sketch this graph. Let's get crazy. All right, cool. So let's go ahead. And before we even get started here with all these guys, let's go ahead and factor this. And it seems that something probably would cancel out here. So let's see. The numerator here is a difference of squares. So we have our x plus 3 and x minus 3 all over. And over here we have an x minus 3 times an x plus 1, right? And that's a negative 3 and then negative 2 there. Good. Yes, very cool. So we can go ahead and eliminate the x minus 3 and the x minus 3, which that means we have a new function now that we're going to be dealing with, which is going to be x plus 3 all over x plus 1. But I'm going to make a little note right here and say, but though, however, x cannot be equal to 3. And this is really the appropriate way of writing it, because if I just gave this to you right now and you didn't know this, then you would not know that we had crossed out this x minus 3. So what you want to do is that you always want to, when you write your new function, go and write it down, but then put like this little quotation right here and then say, but though, you can't plug in 3. Because if you plug in 3, then that means that it won't be part of the original function then. Okay, so let's go on here. So we want to go ahead and find the y-intercept, which means we're going to plug in 0 for x. And so I'm just going to go ahead and use my new function though, because it's a lot easier to use. However, we will get the same answer. So f of 0, so that's 0, 0 over there, and that's 3 over 1. So that's just going to be 3. So that's our coordinate points 0, 3 for our y-intercept. Cool, cool, cool. The x-intercept, let's set the numerator equal to 0. So we have x plus 3 equals 0, which implies that x is negative 3. So that's our x-intercept at negative 3 and 0. Now on to the vertical asymptote. Well, that means what value of x will make the denominator 0? Well, let's see. Well, negative 1, right? So that's going to be our vertical asymptote. X equals negative 1. All right, and then the horizontal asymptote, since our degree of the numerator and the denominator is the same, right? If n is equal to m, then that means it's going to be y equals the coefficient of the numerator divided by the coefficient of the denominator. Well, it's 1 over 1, so it's just going to be 1. All right, so we have a lot of stuff going on here. However, there is one thing, though, that is not on here that I need to discuss, though, and that is, what does it mean when we cross out this negative 3? Does that mean that this x minus 3, or was that one of our asymptotes? That's right. You guys are probably saying that's a hole. That's a hole. That's exactly good. So probably right here, I'm just going to put right here that our hole is going to be at x equals 3. Anytime that you cross out a common factor on numerator and denominator, that's always where the hole is. But more precisely, it's a coordinate point, right? So it's going to be the point 3, and then to find the y value, you plug it into our new function. So 3 plus 3, so that's 6 over 4. 6 over 4 is 3 halves then. Okay, so let me just say that one more time. If you cross out a common factor, that means that this factor is going to be a whole. So I set this equal to 0, x minus 3 equals 0, and then that's how I got 3. So that's the x coordinate of our whole, okay? If you want to find the y value, you plug in 3 back into our simplified rational function, not back into the original, into the simplified one. And so I did that right here. 3 plus 3 is 6, over 3 plus 1 is 4. Okay, so 3 halves. And that's going to be very important. So let's go ahead and plot all this that we have here. Okay, so we have a y-intercept of 3. So I'll put that right there. We have an x-intercept of negative 3. Put that right there. We have a vertical asymptote at negative 1. So let's go ahead and put that right there. Get my little dotted thing. And x equals negative 1, so right here. And we have a horizontal asymptote at 1. We have that. And let's see, we also have a hole at 3 and 3/2. So I'm gonna, so watch this. So 3, 1, 2, 3, and then 1.5, and I'm gonna put a hole right here, which basically means an open circle. Okay, and that's gonna be very important to us because the graph is not defined at that value. If I try to plug in 3 right now, it's gonna be a 0 in the denominator, which is why you can't make it a solid dot right there. Okay. Now wait a minute, my horizontal asymptote should be at y equals 1. Let me just move that up. Ding. All right, you guys probably, hey, what's the one out there? All right, I heard you guys. I heard you. I got it. I got you, dog. I got you. All right. Now, just by looking at the points that we have right now, I mean, do you guys kind of see that it's going to do this, and then it's going to do this guy right here, right? It's going to kind of do that because that's the only way that these graphs can be graphed when you have these points. It's not going to go over here, over there. So, but we do need 5 points, and that will be the prerequisite on the exam. You need to have at least 5 points, and so far right now we only have 3. So let's just do a few more for the sake of this right here. So maybe, I don't know, let's plug in maybe -1. Okay, so what's going to be f of -1, and I'm sorry, you can't plug in -1, right? Because if you plug in -1, that's an asymptote. So let's plug in -2. So let's see, if I plug in -2 there, we get what, -1, right? So I'm going to get -1. So over 2, down 1, right? And I think it's about it right there. So I'm going to go ahead and just draw this in since let me get a different color here though. Let me get like that there. And go like that. And go down just like that. All right. And let's do one more point over here. Maybe we'll do f of 1. Let's do that. All right, so we do f of 1, and we're going to get 2. So f of 1 is 2, and as you can see there, it's going to do this kind of thingamajigger. Ah, shoot. But you shouldn't actually, go over this right here. You should probably just keep your open circle, and it doesn't go through it, though. It kind of like jumps over it kind of thing. All right, so this would be a complete graph. You get full credit here. If you do miss this open dot, then you'll just get marked down a few points, but you won't be completely incorrect, though. But in order to get the full points here, just notice a few things, that we have arrows. And at the ends of our graph, you will get marked down a half a point for each arrow that that you miss, because that means it does go on forever there. You will get marked down if you don't have your open circle, and you have to have at least 5 points. I mean, if you need more, then that means that's fine. But just showing you these little small things that will give a complete graph right there. All right, so there's example number 4.